Good morning friends. In this video, we are going to discuss about the pipe schedule method for a office building which consists of 150 into 100 feet sizing, and we will discuss very detail about the number of steps we have to follow for the proper pipe schedule. So this office building consists of some furnitures and false ceiling arrangements with stock piles with a height of 10 feet. So in office building we have different rooms like HR room, office room, and also we have the storage room also. And this office room consists of lots of furnitures, false ceiling as I mentioned here, and maximum 10 feet height we have the stock piles also. So this one we have to see RSR 1 or RSR group 2 first step. So to based on this one we can proceed further like sprinkler spacing and all this thing. So organizer group 1 mean, for example, you can see here the combustibility is low and the quantity is moderate, and stockpile height mainly it must not exceed 8 feet, but in our case it is 10 feet, so surely it is not organizer group 1. So if you go to organizer group 2 you can see this one, then the height which must not exceed 12 feet. Okay, so in our case it is 10 feet, and so we can say that it is RNSR group 2, and if it is more than 12 feet then it will not come under RNSR group 2, it will go to high piled storage, that is a separate category. So now we know that our hazard is RNSR group 2. For this one we can see what is the production area, what is the sprinkler spacing, and based on that we will make the sizing for the full room. So I mentioned here RNSR group 2, and this is the snapshot from Nfpa 13. So from here the maximum production area of one sprinkler is 130. So that is what I mentioned here, the production area is 130 square feet, and maximum spacing is 15 feet. So area is equal to S max is equal to L max equal to 15 feet. So I will tell you what is this S max and L max. So in this image you can see, for your clear understanding, the distance between the two sprinkler at this level, distance between the sprinkler along the branch pipe, it is S max, and between the branch line this is L max. Suppose in your project the sprinkler is slightly moved away from the branch line, then you have to measure the L max only from the sprinkler, not from the branch line to branch line. So this branch line to branch line, this is not the correct way of measurement. You have to consider the spacing from sprinkler to the next sprinkler in the branch line. So from here you can find out the S max and L max. As per RDSR group 2, it must not exceed 15 feet. And the second important thing, if your sprinkler piping has a sloped surface like you see in the right side image, then you have to measure the piping along the sloped surface. For example, your piping is located like this for the workshop and some warehouses, then you should not measure the piping distance from one sprinkler to another sprinkler like a straight forward like this. You have to measure the piping distance like a slope only. Okay, this is the correct way of measurement first of all. Now the next important step is we have to find out how many branch lines, like here this one, and also in the vertical side like this one as well as the bottom one. So how many sprinklers we have to provide and what is the spacing we have to provide the sprinkler. So we have to find out that step now. So in order to find out that one, number of branch lines, first I consider the width of the bay. The bay means this one, the space total length is 100 feet. So 100 feet divided by L max. So L max means maximum spacing between the two sprinkler, that is 15 feet for the ordinary SR. So 100 by 15 feet, it is 6.67 sprinkler you have to consider. So we have to round off to 7 sprinkler. Now after round off to 7 sprinkler, the total distance is 100 feet divided by 7 sprinkler. That means we have to place each sprinkler with 14.28 feet distance. That means from here each sprinkler should be 14.28 feet distance. And the second important thing is, from the wall to the first sprinkler, it should not be the maximum distance, it should be the maximum distance divided by 2 only for the sprinkler to the wall. So that is the reason the first branch line from the wall is equal to 14.28 divided by 2, so it is 7.14 feet. So here you can see from the wall, first I consider 7.14 feet distance. After that continuously 14.28, 14.28. So it is continuous like this. And the total number of sprinkler based on our find outing, you can see 1, 2, 3, 4, 5, 6 and 7. So this is what we got the answer. Only from the wall you have to find out. For example, here also, this side also, from the wall it is 7.14 feet, and after that continuously it is 14.28 feet we have to add. Now we find out the number of sprinkler and spacing for the one side like this. Now the second step is we have to find out the sprinkler spacing for this side also. I mean the 150 feet this side also. So in order to find out this one, the next step is determine the maximum allowable distance. I mean S max. So you know the total production area for the ordered SR it is 130. So area production is equal to L into S. So S is equal to area, that is 130 for the ordered SR divided by L. So L we already know, that is 14.28. So the answer is 9.1 feet. Okay. So after finding out this one, the 150 feet, that means the total length 150 feet divided by 9.1 feet, and it will give you number of sprinklers, that is 16.48. I round off to 17 sprinkler. So the total with this total length is 150 feet divided by number of sprinklers 17. It will give the answer of 8.82 feet. That is the spacing between each sprinklers. But only from the wall we have to consider this distance divided by 2 only from the wall. So it is 4.41 feet. And now come to this drawing. You can see the value. Here you can see from the wall I have considered 4.41 feet, and between the sprinkler it should be 8.82. It's not 8.88, it's 8.82. And the number of sprinkler you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and finally 17. So this one we got from the calculation. The same you have to follow up here also. So here you can see the total number of sprinkler we have considered 17 sprinkler, and each with the 8.82 feet distance, and only from the wall it should be 4.41 feet. Now you have to verify the maximum coverage is not exceeding the ordinary protection area. For example, ordinary protection area is 130 square feet, and here it is 8.82 feet, which is here, and from the L max we got 14.28. If you multiply both, you will get 135.9, which is round up to 120 feet square, which is not exceeding the maximum protection area of 130 feet square. So the maximum sprinkler spacing is correct. Now we have to proceed for the pipe sizing. In Nfpa 13, you can see the two different material like a steel and copper. So this chart is first for the light hazard. We will see the light hazard, then we will see ordinary extra hazard. So there are two material they have given. One is the steel and another one is the copper. Here you have to see one important difference. For example, this is the C factor or the roughness factor. You can see the black steel here and copper tube. So the roughness value for the black steel, if I use for the wet system, it is 120, and copper pipe it is 150. So copper pipe has high roughness value. That means it has less friction loss. And coming to the steel, it has low friction value. So the friction loss is high compared with the copper pipe. So here in this one you can see for the 2-inch steel pipe, if you use the 2-inch pipe, you can use maximum 10 sprinklers. But when it comes to copper pipe, if you use 2-inch pipe, you can use maximum 12 sprinkler. Similarly, if you use a 2.5-inch copper pipe, you can go till 40 sprinkler. But if you go to the steel pipe 2.5-inch, you can go maximum 30 sprinkler. Because of the less friction rate, the copper pipe you can accommodate more sprinkler. But it is very expensive to use the copper pipe. That's why mostly our preferred choice is steel pipes only. So the very first one, 1-inch pipe can cover 2 sprinkler. So now if you go to the drawing which we discussed in the earlier one, so first you can see here we have the first sprinkler which can be which is served by the pipeline which has 1-inch pipeline, and coming to the second sprinkler, as I told you, 1-inch pipe can cover 2 sprinkler. So for this 2 sprinkler we can use only the 1-inch pipe. Coming to the third sprinkler, 1-inch pipe is not sufficient. So if you go to the Nfpa chart, you can see that for the third sprinkler you have to use 1.25 pipeline, and also till 5 sprinkler you can use 1.5-inch pipeline. Now going to the drawing. So here you can see, so the third sprinkler we have to use 1.25-inch pipeline. When it comes to fourth sprinkler, 1.25 is not sufficient. We have to go with 1.5-inch. So this side it is clear, and all the sprinkler which is from here to here completely follow the same concept. For example, if you see here also, 1-inch pipe can cover till 2 sprinkler. When it comes to third sprinkler, 1.25-inch. When it comes to fourth sprinkler, it is 1.5. So this one is clear now. And going down, so here you can see the total rows in the total number of sprinkler in one rows is, for example, here 1, 2, 3, 4, and also in the left bottom side also you can see 5, 6, 7. So 7 sprinkler is located in one single row. So for the 7 sprinkler, what is the pipe size we have to follow, that we have to see now. So going to the drawing. So here you can see till the 7th sprinkler, I mean after the 5th sprinkler, there is a limit of 10 sprinkler. So till 7th sprinkler, 10 sprinkler, you can use 2-inch pipe. So here we have maximum 7 sprinkler in one row. So that means that the main pipeline, I mean the riser nipple. So here this, if you see the section at this point, this is the cross main line. What you see here, this is the cross main line. And if you see the section, for example, if you see the section at this level, you can see the cross main will be like this. From here the pipe will go up, and from here left and right, so both side we will go. So we saw here 4 sprinkler, which is it is in the left side, and bottom side we have 3 sprinkler, this is in the right side. So this total there are 7 sprinkler adding the left and right side. So this is called as a riser nipple. And for the total 7 sprinkler, as we saw in the Nfpa 13, maximum 2-inch pipe it can cover 10 sprinkler. So for the 7 sprinkler, this 2-inch pipe is sufficient. So the riser nipple size should be 2-inch. Then coming to the next one, now one row we have 7 sprinkler. Coming to the next row, this is again 7. So total this pipeline at this point should cover for 14 sprinkler. So we have to go to the light again the schedule, and here you can see for the 14 sprinklers, after the 10 sprinkler we have 30 sprinklers. So for till 30 sprinkler we can consider 2.5 inch. So in our case we have only 14 sprinkler. So for the 14 sprinkler again we can go with 2.5 inch. So 7 sprinkler again for the 14 sprinkler. So this pipeline will be 2.5. So coming to the third row is 21. So still I can use 2.5. Coming to the fourth row, it is now 7 plus 7 plus 7 and 7. Total it is 28. So till 30 sprinkler I can use 2.5 inch. So till this pipe it will be 2.5 inches. Now coming to the next size, when I add this row also. So 1, 2, 3, 4, 5. When I add the fifth row, the pipe size it will be 35 sprinkler. So when it comes to 35 sprinkler, the number of sprinkler, the pipe size will be different. So now if you see here, after the 30 sprinkler, we have to use till up to 60 sprinkler we can go with the 3 inch. So the next size for that one will be 3 inch. So the next size you can see for the fifth row, 1, 2, 3, 4, 5. So the pipe size which is serving at this point will be the next size, the 3 inch. So like this, one by one you can add and you can size the pipe size. And so the question will come up to what pipe sizes you can consider here. So here there is one important interview question also, you can see here. After this 3.5 inch, that is still 100 sprinkler, they have mentioned for the 4 inch pipe you have to see section 4.5. So they didn't directly mention how many sprinkler you have to consider based on the chart. So that I will clearly explain you what is that. And next point is, so this is done. And second point is number of sprinklers above and below ceiling. So in the right side image you can see this is your suspended ceiling and this is the top slab. You can say the top slab. So here this is the branch line. From the branch line I have taken one line, and above we have the upright sprinkler, and here we have the pendant sprinkler. So this upright sprinkler is for the protection of the ceiling, and this sprinkler at the pendant sprinkler, this is for the protection of the room. So here we have 2 sprinklers. So if we have some type of arrangement like this, 2 sprinklers in one area, then you have to follow this chart. So here you can see for the 1 inch pipe, here it is 2 sprinkler, and here also it was 2 sprinkler, and 1.25 inch it is 3 sprinkler, and here 1.25 inch it is 4 sprinkler, and here it is 1.5 inch 7 sprinkler, and here it is 1.5 inch 5 sprinkler. So this chart we have to follow only if the case like we have upright and pendant same together at a single place. So we have to follow this one. And the next one is the honorary hazard. Here also you can see after some level, for example 6 inch till 275 sprinkler you can cover. When it comes to 8 inch you have to see section 4.5. So here again for these 2 cases we have to go to section 4.5. So first here 1 inch 2 sprinkler, and same concept whatever I discussed now. So the same concept you have to follow here. So in our case now this is the honorary hazard. So for the honorary hazard I have to follow this table. Okay, for our workout. So we have to follow completely this table for the pipe sizing. And here also they have given above and below ceiling. So as I explained before, if you have upright and pendant sprinkler in the same place, then you have to follow this sprinkler's pipe sizing. Now let's see what is C section 4.5. Let's say that 6 inch pipe can cover maximum 275 sprinklers. Now we will go to section 4.5 to understand the concept. And here you can see this is section 4.5. So for the light hazard, they have given 52,000 feet square. That means the maximum floor area in any one floor to be protected by sprinklers by any one system riser. For example, you have a building like this, and here you have one riser here, and there are different levels are there. So from the riser, you are taking the pipeline for the sprinklers. So like this, you are taking the pipeline for the sprinkler. So how many sprinkler can be covered or accumulated in one riser? So that is the answer you have from this one. For example, light hazard, they are telling if the any floor area is more than 52,000 feet square, then you have to go with another riser. One single riser is not sufficient. This is for the light hazard and ordinary hazard, same value. When coming to the extra hazard, if the floor area of any floor is more than 40,000 feet square, then you have to go with another riser. So one single riser is not sufficient to protect. Now if you understand if you want to understand the concept, you have to go to the previous one for example, here you can see one sprinkler protection area in the ordinary hazard is 130 feet square. Now go to the section 4.5, so you can get it easily. So in the ordinary hazard, a maximum 52,000 feet square one riser will cover. So 52,000 divided by, in the ordinary hazard, one sprinkler can cover maximum 130 feet square. So 130. So that means one riser can cover maximum 400 sprinkler. Okay, so if your area, if it is more than 52,000, you have to go with the next riser. So one riser maximum 400 sprinkler only you can accommodate. And coming to the next point, if it is light hazard, what we will do? Light hazard, for example, the maximum production area of one sprinkler, if you are using hydraulic method, it is 225 feet square. So for that case, 52,000 divided by 225. So in light hazard, maximum 231 sprinkler you can cover. So now if you go to the table, you can understand. So here you can see till 3.5 inch 100 sprinkler. So when you coming to fourth sprinkler, here see section 4.5. So maximum 231 sprinkler only covered using the single riser. And the next thing, when it comes to ordinary hazard, for example, here till 6 inch they have given 275 sprinkler. So till 8 inch how many sprinkler we can cover? So as I told you, 52,000 divided by one sprinkler can cover maximum 130. So maximum 400 sprinkler, until 400 sprinkler we can use this one. If it is more than that, we have to go with another riser. So here one important thing is, if the light hazard, maximum 231 sprinkler, until 231 sprinkler I can go. So now how to find out the balance pipe size? For example, here if you see, for the 4 inch, 5 inch till 231 sprinkler, you have to follow this chart. For example, if you have 4 inch pipe, maximum 100 sprinkler, and 5 inch pipe, maximum 160 sprinkler. And if you go to 6 inch pipe for the light hazard, so you can go till maximum 231. So this balance 4 inch, 5 inch, 6 inch, you have to follow this one for the light hazard also. And the last one is the extra pipe schedule. So here also you can see for the different pipe sizes, they have given the number of sprinklers. And if your hazard is extra hazard, then you have to follow this one. But the important thing is the pipe schedule method is not applicable for the extra hazard. There are some conditions that we will see now. So the first point is pipe schedule method shall be permitted as follow: addition or modification to existing pipe schedule. For example, if you have the old building, there already the old people have used the pipe schedule method to size the pipeline. For that, if you want to do any modification because of new addition of rooms, then that time you are allowed to use the pipe schedule method. But for the new building, you are not allowed to use the pipe schedule method. You have to use only the hydraulic calculation method. And addition or modification to existing extra hazard. So if it is a new building extra hazard, you are not allowed to use the pipe schedule method. So additional modification to the existing extra hazard you are allowed to use, and new building maximum till 5,000 feet square area you are allowed to use the pipe schedule method. Over this area you have to go with the hydraulic calculation only. In the pipe schedule method, you have to understand one very important interview question. So for example, here this is the cross main line you have, and this side is the branch line, this side also branch line. So here we have added four sprinkler. So the question is, how many sprinkler I can add if I take one branch line? So you can, as per the Nfpa, maximum you can add 8 sprinkler. Like this, one side you can add 8 sprinkler. For example, 3, 4, 5, 6, 7, and 8. So maximum 8 sprinkler you can add one side, and another side also you can add 8 sprinkler. Suppose your area here it is 100 feet. Instead of 100 feet, your width is very high for your project. So if you want to add the 9th sprinkler at this point, if NFA allows or not, so the answer is yes, you are allowed, but you have to follow two important conditions. So normally we saw the pipe schedule method that for 1-inch pipe it will, for example, 1-inch pipe, if you go to the table, you can see here. For example, let's say it is light hazard. So light hazard 1-inch pipe can cover maximum 2 sprinkler, 1.25 3 sprinkler. So now go to the drawing. So here, for example, so I told you maximum 8 sprinkler is allowed for one branch line. Suppose if you want to consider 9th sprinkler, what you have to do is, this pipe size is 1 inch. So 1-inch pipe can cover maximum 2 sprinkler, but this is what I did so far. But if you want to add the 9th sprinkler, the rule is the second pipe, instead of 1 inch you have to change to 1.25 inch. Okay, if you are changing to 1.25 inch, then you are allowed to use the 9th sprinkler also. Okay, so that is the rule. Suppose if you want to use the 10th sprinkler also, suppose if you want to use the next sprinkler, if you add the next sprinkler also here, so what you have to do is, this pipe is 1 inch as usual, but second pipe you are not allowed to use the 1 inch as you did in the earlier stage. For example, here you see one sprinkler 1 inch, second sprinkler also 1 inch, but if you are adding the 10th sprinkler, then the second sprinkler must be 1.25 inch. 1.25 inch. And coming to the last sprinkler here, the last pipe which is feeding to all the sprinkler, for example, let's say that it is a 2 inch. Okay, because we are adding 10 sprinkler, so it is a 2 inch only. But for the 2 inch, if you go to the drawing, the schedule, for the 2 inch it can cover maximum 10 sprinkler. But the problem here is, we are now adding the 10th sprinkler in the branch line, which is not allowed basically. So still we are adding the 10th sprinkler. So in that case, what you have to do, the last sprinkler it should be 1 inch, and before the last sprinkler, instead of 1 inch it must be 1.25 inch. And coming to the 10th this point which is feeding to the 10th sprinkler, normal case it is 2 inch, but we are adding the 10th sprinkler also. So that time, instead of 2 inch you have to go with the 2.5 inch. So the condition is maximum, as per normal case, 8 sprinkler you can keep in one branch like this. 8 sprinkler you can keep. If you want to keep the 9th sprinkler, then you have to make the changes. Also, if you want to 10th sprinkler, also again you have to make the changes. So the maximum allowed limit is 10 sprinkler only. Suppose in your project the width is very high and you have to go with the next like 12 sprinkler or 13 sprinkler, then you are not allowed to use this type of arrangement. This type of arrangement is called as a tree arrangement. So because here you are taking one cross main, full length you are taking, from here you are taking one left side, one right side. So if you take the section, it will be cross main and both will be left and right side. So this is like a tree. So this is called as a tree arrangement. Suppose your project the width is very high, so tree is not sufficient because you have to add more sprinkler means, instead of taking the tree arrangement, you can take the system as a loop. So it will be like a full loop will be there like this. So from here, for example, here 8 sprinkler you can take, here 8 sprinkler you can take, from here 8 sprinkler, from here 8 sprinkler, like this, 8, 8, again 8 and 8. So you can add total 32 sprinkler in one row. Okay, so this is the advantage of the loop system. So if your case like this, then you have to follow like this. So I hope this method is very clear for you, and if you have any doubt, please don't forget to add your comment in the comment section. Thank you.